Good afternoon, welcome to my channel. Please subscribe, like, and drop your comments. Thank you. We shall be considering mathematics of finance, which is the same thing as mathematical foundations that is required in finance. The aspects that we shall be looking at is the time value of money. We shall be looking at what compounding is. We shall be looking at what discounting is. We shall be looking at how to find the number of years, how to find interest rates. We shall look at what is called continuous compounding. We shall look at perpetuities. We shall look at effective rate of interest. We shall look at annuities. We shall look at how to construct amortization table, and finally we shall consider how to construct the sinking fund table. With the passage of time, money could be affected either positively or negatively. If we consider the concept of interest rates, or inflation, interest rate will have a positive effect. Interest rates will have a positive effect on the value of money as time passes, while inflation will have a negative effect on the value of money as time passes. In the sense that if you hold 1,000 naira, for instance, today, 2021, and by 2022, you get a 10% interest. It means that by 2022, your money would have increased from 1,000 to 1,100, because you would have gotten 10%, which is 100 naira as interest rate on your money. So the passage of time between 2021 and 2022 has affected the value of money positively. The value of your money has gone up positively by 100 naira because of interest rates. Another factor that may affect the value of money is what we call inflation. All of us know that inflation is a general rise in prices of goods and services. So during the time of inflation, if there is inflation, what your 1,000 naira can buy today will be less than what your 1,000 naira can buy this time next year, because prices would have gone up. Compounding is simply calculating the value that a certain amount that is invested today, or a certain amount that is saved today, what it will amount to at a future date. Because that amount that is invested or that amount that is saved will earn what is called interest. And so we can, from today, if we know the interest rate, we can from today calculate the amount which the value which this current amount will turn out to be in future. What we do in compounding is to use interest rates to determine the future amount that you will have if you save or invest a current amount that you have now. The information that is needed for compounding is to know the interest rate, the number of years for which the investment or the savings will be done, the amount, the present amount to be invested or saved, and then how interest is paid. We shall elaborate more on this aspect of how interest is paid as we go on in this topic. Now, picking these items one by one, interest for instance, there is what is called the simple interest, where if you save an amount, let's say the amount you have saved is 1,000, and you are giving interest of 10% per annum, and then the number of years that you wish to save this 1,000 is to save it for 5 years. Now, by simple interest, if you are saving this for 5 years, say this is year 1, 2, 3, 4, and 5. The amount you have saved is 1,000. By simple interest, only this amount will continue to generate interest every year. In year 1, it will generate interest of 10%, and that will be 100 naira. In year 2, it will generate another interest of 10%, and it will continue to generate 100 naira interest every year, because that's 10%. But for compound interest or compounding, what will happen is that this amount you have saved will generate an interest in the first year, and then that interest will also continue to generate interest. That's the difference between compound interest and simple interest, in such a way that both the amount invested and the interest generated will both continue to generate their own interest. The amount invested will generate interest, and then the interest will also generate interest, so that by year 2 you have 1,100, so that by year 2 it will generate interest of 100 naira on that 1,000, and this 100 naira will also generate interest of 10 naira, so that at the end of year 2 you have 1,210 naira instead of 1,200 that you would have had using simple interest. So what we are trying to explain is that in compound interest, the amount, which we call principal, will generate its own interest, and that interest will also continue to generate interest until the end of the period of the investment. The idea behind compounding is that you save or invest a certain amount today and hope to receive a bigger amount in future. You save a certain amount today and hope to receive a bigger amount in future, and it is the interest rate that gives you that hope to receive an amount bigger than what you have saved today. In compounding, interest rate helps us to determine the relationship between the amount you have today and what that your money will grow to become in future. That is, interest rate helps us to determine the relationship between a present amount and a future amount. One of the concepts we shall be considering in compounding is how your savings or how your investment will grow over time due to savings. The other concept we shall be considering is how much you may need to save today in order to achieve a target amount in future. In summary, compounding simply means using a present amount to achieve a future amount. Using a present amount to achieve a future amount simply by investing or saving, so that what brings about this relationship is what is called the interest rate. So compounding simply means using a present amount to achieve a future amount by the relationship which is determined by interest rates. Now let's take an example. That suppose you have a present amount of 100 naira. Suppose you have a present amount of 100 naira and you decide to save this 100 naira in your account for 2 years in your account, and your bank pays interest at 7% per annum. So the question is, how much will this your 100 naira amount to at this future date of 2 years? So if the amount you have invested is 100 naira and the number of years you wish to invest is for 2 years, and the interest your bank pays is 7% per annum. At the end of the first year, what you will have is the amount multiplied by the interest rate, and that will give you 100 naira multiplied by 0.07, and that gives you 7 naira. So at the end of the first year, what you are going to have is 100 naira plus 7 naira. That will give you 107 naira. This is what we will have at the end of the first year. At the end of the second year, using compounding, you will then get the balance that you have now, which is 107 naira, multiplied by still your interest rate of 7%. At the end of the second year, your balance for first year will be multiplied by the interest rate, and that will give you 7 naira 49 kobo. So when you add your 107 plus 7 naira 49 kobo, what you have is 114 naira 49 kobo. This simply indicates that apart from your 100 naira that has generated interest of 7 naira, that 7 naira, so in the second year, this 7 naira has also generated an interest of 49 kobo. This 7 naira has also generated an interest of 49 kobo. So that's how both your principal, your amount invested, and your interest will continue to both generate interest in compounding. Alternatively, we can calculate the future amount or future value as amount invested today into 1 plus the rate of interest multiplied by raised to power number of years, where this is future amount or future value is equal to the amount you have invested today into 1 plus the rate of interest raised to power number of years, where you have here 100 into 1 plus 7% raised to power 2. Then what you have is 100 into 1 plus 7 all over 100 raised to power 2. What you then have is 100 into 1 plus 0.07 raised to power 2. Then you have 100 into 1.07 raised to power 2. And that should give you 100 into. So if you use calculator to determine 1.07 raised to power 2, you get 1.1449. If you then multiply this, it gives you 114.49, which is the same amount that you have here. Let's assume that you invest 200,000. Let's assume that you invest 200,000 in a fixed deposit account in your bank, and the bank has agreed to pay you interest of 13% per annum. And you have decided that you will leave your 200,000 in the bank account for the next 5 years. So the question now is, what is the future amount, or what is the future value that you will receive at the end of the 5th year? So the future amount or the future value you will receive is calculated as amounting to 1 plus interest raised to power number of years. So that's 200,000 into 1 plus 13% raised to power 5. That gives you 200,000 into 1 plus 13 all over 100 raised to power 5. And that gives you 200,000 into 1.13 raised to power 5. You can then use calculator to determine what is 1.13 raised to power 5. If you use calculator to determine what is 1.13 raised to power 5, you get 1.8424. If you then multiply the two, you get a future value or future amount that is equal to 368,480. This simply means that the 200,000 you are investing today at the end of 5 years would have amounted to 368,480. All we have been considering since is with the assumption or with the intention that interest is paid only once in a year. But we know that in reality, we can be faced with a situation where interest is paid more than once in a year. Let us consider the last example where the amount we decided to invest is 200,000 and the interest is 13% per annum, while the number of years is 5 years, where we look for future value or future amount to be the amount invested into 1 plus rate of interest raised to power number of years. So let's assume that unlike the last example we did, this time we are now told that interest is paid more than once in a year. Interest could be paid daily, interest could be paid weekly, interest could be paid monthly, interest could be paid quarterly, interest could be paid biannually. So this situation simply means that there is a multi-period, there is more than one, there is multiple payment of interest during a period of 1 year. There is multiple payment of interest. So what we do in that situation is to account for this multi-period by calling that multi-period, let us represent it as N, multi-period interest payment. So let's represent that situation of paying interest more than once during the period as N. So in this example, let's assume that we are told that interest is paid quarterly. Interest is paid quarterly. Let's assume that we are told that interest is paid quarterly, which means that there are 4 quarters in a year, which means that N will be equal to 4 because there are 4 quarters in a year. So what we do is come here, divide this by the number of times interest is paid in a year, and multiply this by the number of times interest is paid in a year. So in this example where we are told that interest is paid quarterly, which means that interest is paid 4 times, the future value will be determined as amount into 1 plus rate of interest raised to the number of years. So we divide the rate of interest by number of times interest is paid per annum, and then you multiply the number of years by number of times interest is paid. So what we have is amount into 1 plus 13% divided by 4 raised to power 5 times 4. So that gives us 200,000 into 1 plus what's 13% divided by 4 raised to power 20. Once we divide 13% by 4, we have 0.0325. So our future value will then become 200,000 into 1.0325 raised to power 20. If you then raise this to power 20 and multiply by 200,000, you have your value. Raising 1.0325 raised to power 20 gives us 1.8956, and multiplying these two gives us a value of 379,160. Now if you compare this final value to the value we got in the last example, you will realize that this value is higher. So because the effect of paying interest, the effect of multi-period interest payment is that it will give you a future value that is higher. The concept of discounting is the reverse or the opposite of compounding, in the sense that when we are doing compounding, we move from the present into the future. In compounding, we move from the present into the future. But in discounting, it is the opposite or the reverse of compounding, in the sense that we move from the future back into the present. So in compounding, what we are looking for is that we are using the present amount to look for a future value. But in discounting, what we are looking for is that we are using a future amount to look for the present equivalent. Compounding or future value says if you save a certain amount, say 1 million today, how much will you have in future? How much will you have in future? That's what compounding says. Discounting, on the other hand, which is the reverse, says if you need 1 million in 5 years' time, how much should you save today? If you need 1 million at a future date in 5 years' time, how much should you save today? The information required to find a present value from a future amount, say of 1 million, the information required is the interest, the number of years, and how the interest will be paid. Whether it is going to be a one interest per year, or whether it's going to be a multi-period interest payment. So let's take examples, bearing in mind that discounting is the reverse or the opposite of compounding. For example, how much will you prefer to collect immediately? How much will you prefer to collect immediately instead of waiting for the next 3 years to be paid 500,000? Instead of you to wait for 3 years so that in 3 years' time you will be paid 500,000. How much will you prefer to collect immediately if interest rate is 7%? So to determine the amount that you will prefer to collect immediately instead of waiting to collect amount to be waited for equals 500,000 years of waiting equals 3 years. Interest is 7%. So presently, how much will you be willing to collect? The amount you'll be willing to collect presently will be amount into 1 plus r raised to power minus n. You can see that this formula looks the same as future value, which is amount into 1 plus r raised to power n. The only difference is the introduction of this negative sign to the number of years, because like we said, present value or discounting is like the reverse. It's like the reverse. We are coming from 3 years' time into the present. The amount that you wish to collect presently, instead of waiting for 3 years to collect 500,000, will be 500,000 into 1 plus 7% raised to power minus 3. That will give you 500,000 into 1.07 raised to minus 3. If we determine the value of 1.07 raised to minus 3 with calculator, if we determine the value of 1.07 raised to minus 3 by calculator, we arrive at 0.8163, and if we multiply these two, it means that the present amount that you should be willing to collect presently in place of 500,000 in 3 years' time is 408,150. Another way of looking at discounting is to ask how much a future amount will be worth presently. That's considering the equivalent, the present equivalent of a future amount. For instance, how much will a future value of 1 million in 5 years' time be worth today at interest rate of 10%? How much with a future amount or future value of 1 million in 5 years' time will be worth today at interest of 10%. It will be worth amount into 1 plus R minus N. That's 1 million into 1 plus 10% into minus 5. That's 1 million into 1.10 raised to minus 5. Use calculator to determine the value of 1.10 raised to minus 5. We get 0.6209, and if we multiply these two, it means that 1 million in 5 years' time will be worth 620,900 presently. 1 million in 5 years' time will be worth 620,900 presently. Another aspect which we considered under compounding, which we must also consider under discounting, is the fact that there could be multi-period interest payment. There could be multi-period interest payment. So let us assume that in this example, interest is paid quarterly. Let's assume again that interest is paid quarterly. If interest is paid quarterly, my present value then becomes amount into 1 plus R all over number of times interest is paid raised to power minus. Just like we did, you introduce the number of times interest is paid by dividing the interest. You divide the interest by the number of times interest is paid, and you multiply the years by the number of times interest is paid. Another concept we may want to consider under mathematics of finance is the concept of finding the rate of interest. The concept of finding the rate of interest. And the question is, at what interest rate will a present amount of 1,000 naira amount to 2,005 in 5 years? The solution is to find the interest rate. At what interest rate will the amount you are investing today, 1,000 naira, become 2,500 in 5 years' time? So what we do is to divide both sides by 1,000. If you divide both sides by 1,000, you have 2,005 divided by 1,000 equals to 1,000 into 1 plus I square 5 divided by 1,000. This one cancels out. Then we have 2.5. This one divides this and becomes 2.5 equals to 1 plus I raised to power 5. So we then take the fifth root. We take the fifth root of both sides so that we can bring this down. If we take the fifth root of both sides, what we have is fifth root of 2.5 to be equal to 1 plus I. This one goes on. If we then separate these two, what we then have is fifth root of 2.5 minus 1. Subtract 1 from both sides will be equal to I. So I will be equal to fifth root of 2.5 minus 1. If we determine the fifth root of 2.5, we get 1.2011, and then subtracting 1 from it gives us 0.2011. So that if you now multiply by 100, because interest is always in percentage, I then becomes 20%. Another concept under the mathematics of finance is called perpetuities. Perpetuities are annuities, or they are cash payments. They are cash payments that continue forever. They have no end. So what we can calculate under perpetuities is called the present value, and it's calculated as the amount divided by the interest rate. So supposing you have an amount of 5,000 and interest rate of 10%, then the present value, that 5,000 will be paid continuously. You will continue to receive 5,000 without end at interest of 10%. The present value of this perpetuity then becomes 5,000 divided by 0.10, that's 50,000. The next concept we shall consider is what is called continuous compounding. In continuous compounding, interest will be paid continuously without stop. In continuous compounding, interest will be paid continuously without an end. So the future value of, because it's compounding, the only thing we can calculate is future value. Future value of a continuous compounding is the amount invested multiplied by the exponential factor raised to power interest times time. If we assume that the amount invested is 10,000 for instance, and interest is 10% for 4 years, the future value will be calculated as 10,000 multiplied by the exponential of 0.10, which is 10% times 4 years. The exponential factor, if you check calculator, is the same thing as 2.718 raised to power 0.10 multiplied by 4. If we determine the value of 2.718 raised to power 0.10 times 4, what we have is 1.4918. Then if we multiply by 10,000, it means that our future value of continuous compounding gives us 14,918. Another concept under mathematics of finance that we shall consider is the effective rate of interest earned, which is calculated as 1 plus the interest rate divided by number of times compounding is done raised to power number of times compounding is done minus 1. As an example, let us assume that your bank pays interest of 10% per annum. What then will be the effective rate of interest if interest is computed by annually? If interest is computed by annually, what will be the effective rate of interest? The effective rate of interest will be 1 plus 10%, which is 0.1, divided by 2, because the number of multiple compounding is biannually, which is 2 per year, raised to power 2 minus 1. 10% divided by 2 gives us 0.05. If we add that, we have 1.05 raised to power 2, then minus 1, that gives us 1.1025 minus 1. It gives us 0.0. If I subtract 1 from this, it gives me 0.1025. Multiplying by 100, my effective rate of interest becomes 10.25. Thank you for watching. I hope you enjoyed watching.